Hi everyone. In our previous lesson, we covered the tools for select/move and edit pattern. So in this lesson, we will begin by explaining how to edit curve. The edit curve supports editing the positions of curve points on either raw edges or internal lines. It also allows you to add or delete curve points. By clicking on an edge, you can add a purple curve point. Dragging an existing curve point lets you move it to modify the shape of the pattern piece. You can right-click on a point to select Optimize Curve Points. This function adjusts the number of curve points. When you set the value to 20, you will see 20 curve points evenly distributed along a line segment. Then, by right-clicking again and choosing Optimize Curve Points, you can reduce the number of curve points. After clicking, the number of curve points on that line decreases. Next is the Convert to Endpoint function. Clicking it converts the curve points into edge endpoints. Similarly, once they are converted to edge endpoints, clicking again will convert them back to curve points. Following that is the option to delete a curve point or remove all curve points. After clicking Remove All Curve Points, the edge turns into a straight line. The above describes the operations of the Edit Curve tool for edge lines. Next, let's draw an internal line for demonstration. Continue using the Edit Curve tool. Clicking on an internal line adds a point. Clicking and dragging allows you to add a point and adjust the shape of the line segment. Right-clicking on the point provides the same functionality. That concludes the introduction to the Edit Curve tool. Next to the Edit Curve tool, there is a drop-down arrow. Clicking it opens a series of tools to choose from. First, you will see the Edit Arc tool. The Edit Arc function can adjust the shape of a curve or convert a straight line into a curve. You can see that this edge appears as a straight line. By clicking and holding the left mouse button on the line and dragging, it turns into a curve. You can further edit the curve by clicking and dragging to modify its shape. Switch back to the Edit Curve tool. You can see that there are some curve points on this edge. Therefore, when using the Edit Arc tool, the curve may not look as smooth and might even become distorted. In other words, if you want to use the Edit Arc tool, it is best to apply it to a straight line without any curve points. Then, use the Edit Curve tool to select the edge endpoints. You can see that this curve has no curve points at all. It is formed entirely by the manipulation handles. Next, we come to the Round Corner tool. The Round Corner tool is used to check or modify the junction shape formed by the two curves after they have been sewn together. After clicking it, first select the first edge to be rounded. Then select the second edge. Based on which side of the selected point the mouse pointer is closer to, that side is used as the alignment side for merging, thereby adjusting the rounded edge. Next comes the Edit Corner. By holding down Shift or Control, or by using marquee selection, you can select multiple endpoints. When you drag the rounding control and right-click, an Edit Corner editing dialog is triggered, where you can edit settings to create curved corner, rounded corner, or angled corner as needed. Moving on to the Pen tool, this tool allows you to create polygonal pattern pieces or internal lines in the 2D window. And it can also be used in the 3D window to draw lines on the avatar that are converted into pattern pieces. To demonstrate, first click on an empty area. Once clicked, specific instructions appear in the prompt bar below. You can draw a line segment of any length with the left mouse button, or use the right mouse button to draw a line with precise dimensions and angles. Alternatively, by holding down the Shift key, you can draw lines along the horizontal, vertical, or 45-degree directions as indicated by the guidelines. After drawing the desired shape, double-click on the last point to form a closed figure, thereby creating a pattern piece composed entirely of straight lines. When you need to create curves within a pattern piece, hold down the Control key and click to draw a special curve. If you make an error or want to undo your last action, press Delete or Ctrl+Z to revert the step. To cancel the current pattern drawing operation entirely, press Escape to exit the drawing mode. The above describes the operation when the first click is made outside an existing pattern piece. If the first click is made inside an existing pattern piece, the result is an internal shape rather than a new pattern piece. Now let's look at the 3D window application. First, hide the garment and switch to the back view. Then, using the pen tool, draw a line on the model and double-click at the end point to form a closed pattern piece. Next, select the area and press Enter to flatten it into a pattern piece. You will see the pattern piece appear in the same position in the 2D window. This concludes the introduction to the pen tool. Next, we explain the rectangle tool. In the drop-down menu to the right of the rectangle tool, there are many options, with the rectangle and oval tools at the top. The rectangle tool can be used to draw rectangular pattern pieces or internal shapes. Drawing outside an existing pattern piece creates a new pattern piece, while drawing inside creates an internal shape. You can click and drag with the left mouse button to draw a freeform pattern piece, or click with the right mouse button to draw one with precise dimensions. It also supports drawing a square pattern piece of any size by holding down the Shift key. Switch to the oval tool. This tool can likewise be used to create oval pattern pieces or internal shapes. If you need to draw an ellipse, simply click and drag. If you need to draw a perfect circle, hold down the Shift key while dragging. Next is the internal dart. The internal dart function can generate a diamond-shaped notch structure within a pattern piece. Click on the pattern piece at the position where you want to insert the internal dart. In the pop-up window, you can set the widths for both sides and the height. You can also check the sewing option to configure the sewing direction and seam side. By default, the sewing option is enabled. Here, we disable it. After clicking OK, the internal dart is created. This demonstrates the effect without automatic sewing. Do it again, but this time check the sewing option to see the effect. Press the spacebar to simulate, and you'll see the state with automatic sewing applied. Click on the internal dart and press Delete to remove it. Then try drawing the internal dart by dragging directly. Internal dart drawn this way will not have sewing lines connected and their dimensions may not be as precise. Therefore it is best to click and then input specific values to generate the dart. Next is the dart function, which creates pointed darts along the outer contour. Click at the hem to bring up a pop-up window. There, you can set the dart's depth and width, its sewing status, and the seam side. Click the seam side button to see the purple reverse orientation indicator change. Click OK, and the dart is created. If you are not satisfied with the dart's effect, you can right-click on it and choose Edit Dart. Then, adjust its parameters again in the pop-up window. Alternatively, you can also edit the dart using the Select/Move or Edit Pattern tool by right-clicking. Right-click to delete the dart. After deletion, the two edge endpoints still remain. If you do not need these endpoints, you can right-click to convert them into curve points. Next is the Cancel Dart function. Clicking it will cancel the dart. Unlike Delete Dart, Cancel Dart does not revert the pattern piece to its original state. And it preserves the original sewing relationships. Finally, there is the Rotate Dart function, which allows you to perform a single dart transfer or convert a single dart into multiple darts. First, for a single dart transfer, click the function and then select a point on the raw edge to determine the new dart position. Double-clicking will bring up a pop-up window where you can modify the transfer amount and direction. Click OK, and the rotate dart is complete. Next, to demonstrate converting a single dart into multiple notches, right-click the Rotate Dart function again and select multiple points on the raw edge. Double-clicking will bring up a pop-up window where you can set the parameters according to your needs. Click OK to complete the multiple dart transfer. Next is the Spiral tool, which can generate a spiral pattern piece. Click in the 2D window, and a pop-up window for creating a spiral pattern piece will appear, offering a series of adjustable parameters. The radius setting determines the initial radius of the pattern piece. Length is divided into inner and outer segments, corresponding respectively to the inner and outer spiral lengths of the pattern piece. The width is also divided into inner and outer, corresponding to the widths on each side. The offset refers to the distance from the spiral point to the edge. The direction can be set to rotate either clockwise or counterclockwise. Once completed, click OK to generate the spiral pattern piece. Next is the Add Point tool, which allows you to add points along a line or split a line into two segments. Using the sleeve cuff as an example, you can simply click on the line to add a point, or right-click to add points at specified intervals. After right-clicking, a pop-up window will appear where you can set the point addition position or segmentation method. You can freely set the number of evenly spaced segments, and then click OK to complete the point addition. Next is the Notch tool, which allows you to add, move, or edit notch on the raw edge. Click on the raw edge to add a notch at that position, or right-click to add notch at specific intervals. You can choose to add a ratio notch or a fixed distance notch. First, add a ratio notch. Then click the Edit Pattern tool to change the raw edge length. You will see that when the raw edge length changes, the notch's position adjusts proportionally. Next, add a fixed distance notch. Now, when you change the raw edge length, the notch follows the selected line segment, and its distance remains unchanged. In addition, you can select a notch with the left mouse button and drag it to move its position. It also supports selecting a notch and adjusting its type, display color, and other parameters in the property editor on the right. Similarly, if you wish to delete a notch, you can select it and either right-click to choose Delete or press the Delete key. Next is the Pleat tool, which allows you to insert one or more pleats along the raw edge. First, use the Rectangle tool to draw a pattern piece for demonstration. Then select the Pleat tool, and you will see operational prompts at the bottom. Following these prompts, select the starting point, the ending point on the outline, and the side where you want to insert the pleat. Then, set the pleat parameters in the pop-up window. First, choose the category of pleat, which can be a full pleat, a half-open pleat, or a center pleat. Next, choose the pleat type, which can be a knife pleat, an inner box pleat, or an outer box pleat. Here, a knife pleat is demonstrated. The number refers to the number of pleats to be added, which can be adjusted freely. The interval refers to the vertical distance between each generated pleat. By default, the ratio is fixed. During adjustment, you can disable the fixed ratio to set different vertical distances as needed. Once set, the differences will be visible in the 2D window. You can also set the pleat width on the start and end edges, which determines the folding quantity of each pleat. There is also a fixed ratio button on the right side. Once the fixed ratio is turned off and you input different values, you can create pleats that resemble a fan shape. Next is the Fold Reverse function, which lets you view the orientation of the pleats. Once selected, the pleats can be set to face in the opposite direction. Next comes the Create Notch. Notch can be created at the pleat positions for production alignment, and you can enable this option as needed. Further down, you can adjust the initial 3D position, as well as the fold angle. You can also choose whether to generate sewing lines at both ends. After making this selection, you must adjust the seam length according to the pleat interval and number. Additionally, you can choose to apply the realistic fold option to all pleats to achieve a natural folding effect. Once complete, click OK and the pleats will be generated. Use the Fix Pin tool to secure both sides, then check the sewing status. Click Simulate, and you will see that the pleated effect along the lower edge looks quite good. It should be noted that if the seam length does not fully correspond to the pleat folding amount, it may result in fluttering, so be sure to match the lengths accordingly during production. Next are the inner box pleat and outer box pleat, which operate in a similar manner and will not be elaborated on further. Expanding the drop-down reveals the pleat fold tool, which quickly sets the folding angle for the internal lines of the pleats. For a demonstration, click the pleat fold tool, select the starting point, then double-click to choose the end point. A pop-up window will appear, allowing you to set options for knife pleat, accordion pleat, inner box pleat, and outer box pleat, as well as to choose the number of internal lines for per pleat according to your personal preference. For knife pleat, when the internal lines are not outlined at 180 degrees, 2 internal lines form one cycle. If all internal lines are outlined, 3 internal lines form one cycle. For accordion pleat, the default setting is that 2 internal lines form one cycle. For inner box and outer box pleats, when neither of the 2 180-degree internal lines is outlined, 4 internal lines form one cycle. If one 180-degree internal line is not outlined, 5 internal lines form one cycle, and if both are outlined, 6 internal lines form one cycle. You can also adjust the fold angle and other parameters without further elaboration. There is also the pleat sewing tool, which quickly sews the pleat structure. It is primarily used when there are many regularly arranged pleats, allowing for the rapid generation of multiple sewing lines. Next is the trace tool, which can generate internal lines from the baselines in DXF pattern data. Right-clicking on a baseline allows you to convert it into an internal line or an internal shape. If you want to trace the entire shape, double-click to select it, then right-click to convert it into an internal line or internal shape. Here, you can notice that one function is convert while the other is trace. Let's examine their differences. When you use convert and move the shape, the baselines are removed from the original position. In contrast, when you use trace and move the shape, the original baselines remain intact. Therefore, you can choose whichever method suits your needs. When you select a complete closed shape, you can also right-click to trace it as pattern. Clicking will create a copy of the pattern piece, and its shape and position will be clearly visible in the 3D window. Next come the cut and sew tools. The cut tool splits a pattern piece along a chosen line, while cut and sew not only cuts along that line, but also reconnects the pieces with a sewing line. Following that is the fullness point tool. In its drop-down, you'll find 2 options, fullness point and fullness line. First, let's explain fullness point. This tool splits a pattern piece into 2 parts and rotates one of them. When you need to add ease along a line, click the start and end points of the cut, and select the side to rotate. Then, dragging the mouse unfolds the pattern piece. If you need a specific extension, right-click to choose the extension distance or angle. Next, fullness line allows you to increase the raw edge length on one side of the pattern piece while keeping the other side fixed. You select the lengths for the starting and ending sides and set the parameters in the pop-up, specifying the extension length, so that by adjusting the overall length or movement distance, the shape of the pattern piece is altered. Just be sure to note the difference between the slash line length and the fullness line length during the process. Following that is the seam allowance tool, which lets you set seam allowances on the pattern piece for production data. Clicking it will automatically generate seam allowances for all pattern pieces. If you wish to delete them, simply select all and press delete. You can also marquee select individual or multiple pattern pieces to reapply seam allowances, or right-click in an empty area to create seam allowance by default. Once generated, you can select a seam allowances and edit its parameters in the property editor on the right. Next is the Add Annotation tool. This tool allows you to insert or edit annotations on a pattern piece or raw edge. To demonstrate, click on the pattern piece to start typing an annotation and then click on an empty area within the pattern to finish. Alternatively, you can click on a raw edge to insert text, which will appear outside the raw edge, useful for print production. Clicking an annotation lets you adjust its text, font size, color, offset, and other settings in the property editor. Next is the Edit Grading tool, which supports editing the grading information of a pattern piece. It allows you to edit edge endpoints, and once selected, you can configure the grading information in the Properties panel. Right-clicking also lets you remove graded size, copy, flip the grading horizontally, and more. Edit grading function details can be found in the related instructional videos from our YouTube channel. Next is a series of tools for sewing. The first one is Edit Sewing, which allows you to adjust the length and parameters of sewing lines. You can see that there are already some sewing lines in the window. Click on a sewing line to adjust various parameters in the property editor on the right. Sewing lines are classified into two types, flat seam and turned. Flat seam can be further divided into one side and both side flat seams. You can also adjust the fold strength, fold angle, elasticity, and 3D seam side effect to achieve a specific sewing result. Clicking on a sewing line brings up right-click functions. The first option is Deactivate Sewing. After applying it, adjust the 3D window for a better view. After simulation, you will notice that this sewing line appears gray, and there is no stitching effect between the pattern pieces. If you want to reuse the sewing line, right-click and select Activate, then you can continue the simulation. Next is Reverse Sewing. Clicking it will change the sewing line to an interlaced stitch pattern. This is useful if the sewing line was mistakenly stitched in reverse. The shortcut key for this is Ctrl+B, allowing for quick switching when a sewing line is selected. Next, you can add point on the start and end or add seam line top stitch. First, let's demonstrate Add Seam Line Top Stitch. Clicking it will add a visible top stitch along the sewing line inside the pattern piece. Next, let's demonstrate Add Point on the start and end. Since the sewing line currently reaches the edge, the effect is not visible, so we will shorten the sewing line first. After clicking Add Point on the start and end, switch to the Edit Pattern tool, and you will see that points have been added along the segment based on the sewing line's length. The last function in the right-click menu is Delete, which removes the selected sewing line. Now, let's move on to segment sewing. Segment sewing allows you to sew two separate lines together. Clicking the drop-down arrow gives options for segment sewing and end segment sewing. First, let's demonstrate segment sewing. Click the two lines you want to sew together in sequence, and a sewing line will be created between them. Next, let's demonstrate end segment sewing, which supports sewing two sets of non-continuous segments together. Click each line in the first set in sequence, then press Enter. Then, click each line in the second set in sequence and press Enter again. A multi-segment sewing line will be generated, sewing the back armhole segment to the back piece. The two sewing segments will automatically align based on their length ratio. Next is free sewing, which allows for more flexible sewing between two segments with any start and midpoints. Follow the on-screen instructions, click the start and end points of line A. Then, click the start point of line B. When approaching the end point, a blue equal length guide will appear. Clicking it will complete the free sewing of the segment. In free sewing, you can also click the drop-down menu to select End segment free sewing. It supports sewing two sets of non-continuous segments with any start and end points. First, click the lines in the first set, then press Enter. Next, click the lines in the second set, then press Enter again to complete the multi-segment free sewing operation. You will see that this sewing group consists of two separate sewing lines. Additionally, when using segment sewing or free sewing, you can hold Shift to multi-select and achieve a similar multi-segment sewing effect. Delete the sewing lines and perform another demonstration. Using the segment sewing tool, hold Shift and select the first M segments, then release. Hold Shift again and select the next N segments, then release. This completes the End segment sewing. Using the free sewing tool, hold Shift and select the first M segments, then release. Hold Shift again and select the next N segments, then release after finishing the selection. This completes the End free sewing. Next is the Fold Arrangement tool, which supports folding internal lines or sewing lines on pattern pieces to achieve specific effects. Use the pen tool to draw an internal line here as a folding demonstration. Zoom in on the 3D window and focus on the cuff area. Then, use the Fold Arrangement tool to select the internal line. Note that if you select it in the 2D window, the fold positioning sphere will not appear. It only appears when selected in the 3D window. The sphere contains a fold operation line, which assists in folding the pattern piece. Meanwhile, the fold angle in the right side property editor updates dynamically during the folding process. This function can be applied to cuffs, hemlines, or other areas requiring a folded effect, helping to enhance the garment's realism. Next is Fold Garment, which allows folding individual pattern pieces or the entire garment. Select this function from the Fold Arrangement drop-down menu. After enabling the function, click in the 3D window to determine the folding location. Click the designated area, rotate slightly, and you will see the positioning sphere appear. Select the operation line to complete the pattern folding. To fold the entire garment, select all pattern pieces before folding. Next is Set Sublayer, which adjusts the layering order of pattern pieces. In the 3D window, you can see that the sleeves currently have two layers, both set to layer 0. Let's use these two sleeves for demonstration. Using the Set Sublayer tool, drag to adjust the layer hierarchy. Click the plus symbol and minus symbol buttons to modify the front-to-back order of the layers. During simulation, you can clearly see the pattern layers shifting and alternating their stacking order. Next is Add Tack, which connects 2 points from 2 different pattern pieces. This function supports selection in both the 2D window and the 3D window based on positioning. After simulation, the 2 tack points will be linked together. Clicking the drop-down arrow opens the Tack to Avatar option, which functions similarly. It allows you to connect a point on the pattern piece to a point on the avatar. Draw a small pattern piece. Using Tack to Avatar, click both the pattern piece and the avatar. After simulating, you can see that the pattern piece is attached to the avatar's hand, with a sewing effect visible. Next is the Edit Tack feature. Select the tack in the 3D window, and in the right side panel, you can edit the length of the tack line segment. To delete the tack, simply select it and press Delete. After simulating, the pattern piece becomes detachable and will fall down. Next is the ironing brush tool. Click to open it, and there are also flatten brush, subdivision brush, solidifying brush, and strengthen brush options. Let's demonstrate each one. The ironing brush is similar to an iron, and it stretches or shrinks the pattern piece mesh. After clicking the pull brush, you can switch between the brush or eraser tools here. By default, the brush is selected. You can adjust the warp and weft directions, radius, and hardness effect, as well as options like whether to cross sewing lines and whether symmetry is supported. Currently, the brush color is blue. When the warp is greater than 0, the brush color turns red, indicating stretching. The more the stretch, the redder it becomes. When both warp and weft are greater than 0, the stretching is more intense. If both warp and weft are less than 0, the brush color turns blue, indicating shrinking, with a deeper blue representing stronger shrinkage. Note that when the weft is less than 0 and the warp is greater than 0, it still shows a stretching effect. To remove the applied pull brush, you can use the eraser to delete the brush strokes. Alternatively, right-click on the pattern piece and select Remove Steam on selected pattern, or Remove all steam. You can also hold Ctrl and click to remove specific pull locations. Next is the flatten brush. The flatten brush is similar to the ironing brush, with both having an iron-like function. However, unlike the ironing brush, the flatten brush is only used for flattening fabrics and does not change the size of the pattern mesh. Next is the subdivision brush. The subdivision brush also has brush and eraser tools. It allows for local refinement on specific pattern pieces. When you open the fabric grid, the effect is more noticeable. Here you can adjust the particle distance for the local refinement. Click on the pattern piece, and you can clearly see the difference in particle distance. The overall particle distance is 20, while the refined particle distance is 5. So, the difference is quite noticeable. Next is the solidifying brush and strengthen brush. Like the subdivision brush, the solidifying brush and strengthen brush are used to apply local solidify or strengthen operations on pattern pieces. These tools help adjust the details of the garment more effectively. Next is the fix pin. You can select part of the mesh on the pattern piece, and during simulation, the selected area will remain stationary. This effect is similar to a local freezing effect. Let's demonstrate with a rectangular selection. Select Fix Pin, then click the middle of the pattern piece to fix a single mesh. Double-clicking the edge will fix the entire edge. Double-clicking the interior of the pattern piece will fix the entire pattern piece. Right-clicking on the Fix Pin will allow you to delete the selected pin, or delete all pins on the selected patterns. Let's now simulate the fix pin effect. Click Simulate, and you'll see that the pattern piece with the fix pin will not fall down. Even if you use the gripper to pull it, it will not detach. Next, right-click and choose to attach pin to avatar to see the effect. In the 3D window, you will see that the fix pin will move along the avatar's contour lines and align with the avatar. During simulation, it will be seen as tightly attached to the avatar. Right-clicking and selecting Detach all pins from avatar will release the fix and move it away from the avatar. Similarly, in the 3D window, you can also right-click to detach the fix pins from the avatar. Next, there are actions for all fix pins, which work similarly, so I will not go into further detail here. Clicking the drop-down arrow reveals that we just used the Fix Pin box tool. There is also a Fix Pin brush tool. Clicking this tool will pop up a window where you can adjust the radius for fix pins. Next is the Fix Pin lasso tool. This tool functions similarly to the Fix Pin box tool. It supports lacing to fix the mesh, and you can also use Control to select and delete specific meshes. Right-clicking will offer the same options, so I won't elaborate further. The Select Mesh box tool is also available in the drop-down. This tool allows you to select a mesh and drag to move its position. The method for selecting meshes is the same as with the Fix Pin box tool. The difference is that once selected, a directional axis will appear in the 3D window, assisting with the mesh dragging. For Fix Pin, the directional axis only appears after you click. You can also hold Control to select and delete specific meshes. Another difference is that when using the Select Mesh tool, there will only be one mesh area on the page. However, multiple fix pins can exist. Next is the Select Mesh lasso tool. It works the same way. You can click to select a single point, double-click to select the entire mesh of the pattern piece, or drag to select a specific area. During simulation, you will see that the tool can only drag the mesh, but cannot fix it. So, during use, you can combine the Fix Pin tool to perform the fixing operation. That's it, guys, and I hope some of the tips will help your modeling work. If you like what we do, please liking, commenting, and sharing this video. Thanks so much for watching, and I will see you in next video. Goodbye.